Welcome to the webinar of the Blinkduino demo of EICASLAB. Blinkduino is a practical demo showing the EICASLAB target operative mode at work, with special focus on the EICASLAB key feature automatic code generation for hardware target. In this demo, the hardware target that we will consider is an Arduino board. The EICASLAB target operative mode enables the automatic code generation for hardware target key feature, that we will also simply call ACG for hardware target, that generates the real-time control program for the hardware target, and the execution in real time of the hardware in the loop and final validation test. For exploiting the overall capabilities of the EICASLAB target operative mode, you need the EICASLAB base, that is the core of the EICASLAB software suite, the EICASLAB ACG module, enabling the generation of the application software source code, and one or more EICASLAB target module managing the overall functionalities, such as basic software and code transfer, related to the target with which you intend to operate. EICASLAB provides a set of target modules, each one managing a family of hardware targets. In this demo, the hardware target module for Arduino boards with AVR microcontroller will be considered. The code generated by the ACG for hardware target is subdivided in two main components: the application software, representing the target independent part of the final code, implementing the control algorithm, which is generated by the EICASLAB ACG module, and the basic software, representing the target-dependent part of the final code, which is generated by the specific EICASLAB target module. Compiling the generated source code produces the real-time application, which has to be transferred to the final hardware target which controls the real plant. The Blinkduino demo uses the EICASLAB target module for Arduino boards and works for Arduino boards with ATmega 328 microcontroller. We will show you now how to program your Arduino board with EICASLAB in order to blink its external LED. The aim of the Blinkduino demo is to generate and transfer a minimalistic open-loop algorithm to an external hardware. Since no real-time operation will run on the PC running EICASLAB, no real-time operating system is needed. On the other hand, an Arduino board, or Genuino outside the United States, with ATmega 328 microcontroller on it, is needed for the role of external hardware to be programmed. The target is connected to the PC through a USB to serial converter, allowing to program the AVR microcontroller using the AVR toolchain utilities. To have more information about the requirements and other common issues, give a look at the Blinkduino user manual and its FAQ section. Having at disposal the EICASLAB target module for Arduino, you can easily generate the code for the Arduino target and, using the AVR toolchain utilities, cross-compile and then transfer the code to the flash memory of the external microcontroller board, as we will now see, showing a practical demonstration of the software. Let's now proceed with the practical demonstration. We will use a PC connected through a USB to serial device to an Arduino Ethernet board. Let's now work with the software. Once you have launched the EICASLAB demo from the desktop link or from the installation directory, select in the Master Tool window the menu Demo and open the project Blinkduino included in the demo. The Sim Builder tool gets opened, showing the graphical system layout of the demo project, which is very simple. It contains a processor block assigned, as indicated, to the target My Board, that represents an Arduino board to which the PC is connected through a USB to serial device. You can check the current configuration of the target by opening the target parameter file through the menu Target, Configuration, Setting. The configuration of the target depends on both the host and target system. The processor block contains an inner layout that you can open double-clicking on it. It includes two blocks: the control block, where the application software is implemented, and that in this simple case contains a routine which toggles the binary value of a variable, and an interface block, representing the digital output connected to the LED to be blinked on the board. The digital interface has a set of parameters that you can view and edit double-clicking on the block. You have the hardware pins to be controlled, their default state and the output mode. In this presentation we are connected to an Arduino Ethernet board, and then it's necessary to indicate that the board has its built-in LED on the D9 pin. Let's now consider the scheduling parameters that, in this case, describe how the target must execute the activities. Select the scheduling menu of the Sim Builder tool and open the Activity Scheduling window. Having just two activities, the demo scheduling is simple. The two activities work sequentially. The control updates a digital variable. Then, the hardware pin toggles its state. So, the two activities are on the same thread, the thread number 1, that has period 1. Consequently, the algorithm which blinks the LED is executed every tick time. Changing the tick time or the thread period, you can vary the blinking period as desired. When the configuration is completed, you can create, build and export the blinking program to the external board. For doing this, select the Global Data menu of the Sim Builder tool and open the Global Data window. Then select the target My Board and click on the ACG AS+BS button. The ACG for target window gets opened, allowing to generate the whole real-time software to export to the board. Click on the Export button. You first decide in which directory exporting the code. Then, the program remembers you that the board doesn't manage files, and consequently, the parameters and the states have to be initialized directly in the code. Do not mind about it for the Blinkduino demo. Finally, the code is generated. The AS+BS code generated by ACG must be cross-compiled to become a program executable by the AVR microcontroller of the external board. By default, the last generated code is compiled, but you can compile any code previously generated. For compiling, you have just to click on the Compile button. At the end of the compiling process, a log report is shown. The compiled output is a binary executable for the external hardware target, ready to be transferred to the flash memory of the board. For doing this, you have just to click on the Upload button, and EICASLAB will use a device programmer software for uploading the code. When the upload is completed, the board starts executing the program and then blinking with the required period. The webinar of the Blinkduino demo of EICASLAB is finished. Thank you for your attention. More information about the demo and more generally about EICASLAB are available from the online resources of EICASLAB.com website. For any further information, please contact support@eicaslab.com.